This is once again Haribabuprasad Damarla. In this session, we will discuss the switching hierarchy and routing principles in telecom networks. Switching hierarchy and routing. Exchanges are interconnected by a group of trunk lines. Two exchanges, say for example exchange A and exchange B, are connected by a group of trunk lines. So in our digital era, we can say number of PCMs. Each PCM which can support up to 30 voice conversations. The group of trunk lines are known as trunk groups. So the other name is trunk groups. The trunk groups carry traffic in one direction. That means if you are having one trunk group between A and B, it can carry the traffic either from A to B or B to A. For both way communication, you do require the other group. So let us see. Therefore, two trunk groups are required between any two exchanges. With reference to A, if you consider one trunk group as A to B or outgoing from A, there should be another group which is B to A or incoming to A exchange A. Then for interconnection of these exchanges, we adopt different topologies. There are mainly three topologies. One is star topology, the other one is mesh topology, the other one is, the third one is hierarchy topology. So we will try to understand the basic concepts of these three topologies. So let us try to understand with the help of these diagrams. So first we will discuss about star topology. A star topology utilizes an intermediate exchange called tandem exchange through which all other exchanges communicate as shown in figure A. So let us look into this figure. There are four exchanges which are interconnected through the tandem exchange T. Suppose this exchange or the customers of this exchange, they want to speak with the customers of this exchange, they have to pass via the intermediate exchange, and the name, the technical name for this intermediate exchange is known as tandem exchange. So in this example, this tandem exchange is interconnecting four exchanges. Further, we will look into star topology. Star networks are used when the traffic levels are low. So these star networks are more ideally suited for low traffic situations. Many star networks may be interconnected by using additional tandem exchange, leading to 2/3 level star networks as shown in figure B. Suppose if you can see here, so there are so many tandem exchanges. So suppose a person from this exchange wants to speak with a person connected to this exchange. So he has to pass. So the user from this exchange is to be first switched to tandem exchange, this tandem exchange. Let us say tandem exchange 1. Then further the call is to be switched to this tandem exchange 2, say. then to the final tandem exchange or the tandem exchange 3, and finally he will be connected to the customer or the subscriber or the user of this exchange. So 2 or 3 or even more tandem exchanges are involved when more and more exchanges are interconnected. They need not be connected with a simple one tandem. So there may be more number of tandem exchange from source to the destination connection. So that is the meaning of it. Now we will look into the concept of mesh topology. Mesh topology is a fully connected network, and the number of trunk groups in a mesh network is proportional to the square of the exchanges being connected. So here you can see this is the mesh topology. Each exchange is connected to all other remaining exchanges. So many interconnections. So the number of trunk groups, so there should be trunk group from this exchange to this exchange, this exchange to this exchange, this exchange to this exchange, like this. So here the number of trunk groups required is proportional to the square of the number of the exchanges in this mesh. Here you can see there are 6 exchanges, 1, 2, 3, 4, 5, 6. So the number of trunk groups required is equal to 6 square, that is 36. That is the barest minimum required. As a result, mesh connections are used only when there is heavy traffic among exchanges, as may happen in metropolitan area. So here you require more number of trunk groups or connections. So generally this mesh topology is adopted where you have more traffic, and it is ideally suited and must for metropolitan cities like Chennai, Bangalore, Delhi, Bombay, Calcutta, and so on. So mesh topology is generally adopted in metropolitan cities. Then the third one is hierarchy topology. So what is this hierarchy topology? We will try to understand step by step. Simultaneously, we will look into this detailed drawing. Okay, here subscriber A wants to subscriber B. So the subscriber A and B may be located anywhere in the world or anywhere in the country. So how they will be connected in a hierarchical step-by-step mode. So that we will try to understand. Hierarchical networks are capable of handling heavy traffic and at the same time use the minimum number of trunk groups. The main advantage of the hierarchical type of networking is they are very much ideal for not only heavy traffic, but they do require minimum number of trunks. They don't require the number of trunk groups as required in the mesh. So that is one main advantage. So it can handle heavy traffic and the trunk groups required are also reasonably minimum. A 5-level switching hierarchy is recommended by CCITT, that is the older name, The present name is International Telecom Union ITU as shown in the figure. So CCIT has recommended any two customers should be connected by following 5 level of switching hierarchy. Just let us scan through the drawing. So the user A is connected to the local exchange at LA, local exchange area. This is local exchange area. Then the second level is primary exchange area, primary area. Then secondary area. Then tertiary area. Then finally quaternary area or quaternary center. So then the other direction from A to B, this QA is connected to other side QA, and this which in turn connected to tertiary center, then secondary center and primary center and local exchange. So the exchange to which the subscriber B is connected. So you can see 1, 2, 3, 4, 5 levels. Similarly, subscriber A also is connected by means of 5 levels. Further, we will discuss what is the meaning of local area, primary area, secondary area, tertiary area, quaternary area. In a strictly hierarchical network, traffic between subscriber A and subscriber B flows through the highest level of hierarchy, that is quaternary centers. So theoretically speaking, in this hierarchical topology, the customer A is connected to B or vice versa. So through this quaternary centers, this is the final level. So there are other levels at which these customers can be connected. That we will look into it in the next slide. A traffic via the highest level of hierarchy is known as the final route. Via this route, if A and B, if A follows this path, reaches up to quaternary center or quaternary area, and is connected to the other sides, B side quaternary area, this is known as the final route. This is the ultimate route through which at any cost the connection between A and B should be completed. However, if there is a high traffic between any pair of exchanges, direct trunk groups may be established between them as shown in the dash lines. These direct routes are known as high usage routes. Now let us see the dotted connectivity. So this primary center is connected to this side primary center, B side primary center, because there is heavy traffic, considerable traffic between this primary exchange and this primary exchange. That means the call between A and B need not pass up to QA level. So A is connected to this local exchange. From this local exchange, it can go to the primary exchange, PA, primary area, and this primary exchange area, this primary exchange is connected to this side primary exchange, and the call can be completed here itself. So this is the first preferable choice, so that we can avoid all these stages and the switching is fast and we need not utilize the resources of other connectivity between different levels. Whenever high usage routes are available, these routes are known as high usage routes where traffic is more. Whenever high usage routes are available, the traffic is primarily routed through them. In case of traffic overflow, the traffic is routed along the hierarchical path. Suppose as long as the number of the trunks or the lines available between this primary center and this primary center are sufficient to meet the traffic requirement from this area to this area. So this is the preferred one. So in this path only it will go. Suppose this is not, this is traffic is overflowing and this could not meet the number of calls from this side to this side. At that time, perhaps it may go to next level. So as shown in this diagram, for example, so this TA is connected to this secondary center. So this way also, if this is not possible, so this is another alternate path, shortcut path after this, and it may also be connected like this. Suppose this is also is not catering, the lines are not sufficiently available for a specific call, then the other path, third choice is TA to TA, tertiary center to tertiary center. If this way also we can avoid another step. But any cost, even this is overflowing, finally the call should mature and the connectivity between A and B should be established in this example, at least through final level, that is quaternary level. So this is what it is explained here. No overflow is permitted from the final route. So traffic should not overflow beyond final route. Beyond this, there is no other route available. So we have to design the network in such a way that in the worst condition, the connectivity should happen at VA level. So for example, we can consider this QA as the India, we will take an example. In a country, India, we will take as an example. So we have important zonal nodes like Madras, Bangalore, then Calcutta, New Delhi, Bombay. So we can consider them as QA. So zonal headquarters centers. Then this is a TA or the tertiary center. This we can consider as the state headquarter. Okay, the state level exchange can be considered as TA. So SA can be considered as the secondary center. It is something the nodal center of a district. Then this primary center can be considered as a subset of a district. Each district may be divided into, say for example, from 10 to 15 primary areas. So each district is subdivided. So the nodal center of this subdivided district centers are known as primary centers. Then this is the local exchange area. Within the subdivision, there may be different exchanges. So they are known as the local exchange. The exchange in your village, town can be considered as local exchange. Further, we will study the figure C, this one. The first choice routing between subscriber A and subscriber B is the route across the primary centers. So as indicated here, so this is the first choice. As long as this path or the trunk line between this primary center and this primary center is available, so the call should be put through via these two primary centers. This is the first choice. Suppose this already I have explained. Once again, I am reiterating. The second choice can be something like this. The third choice is through state headquarters. The final and ultimate choice is through zonal headquarters like Bombay, Delhi, Calcutta, Chennai, Bangalore. Okay. The second and third choice of routes and final routes are also indicated. So this is second, third, final. A hierarchical system of routing leads to simplified design of the network. So when we follow this hierarchical routing, so this is the best and the simplified designing of the networks. This is generally followed in the industry. Now we will try to understand the routing principles or the methods. How a call is routed from calling party to the called party. What are all the different methods and the basic concept of these methods we will try to understand in this slide. There are three methods that are commonly used for deciding on the route for a particular connection. So there are three methods for routing the call between the calling and the called subscriber. The first one is known as right-through routing. Right-through routing. The second one is phone exchange routing. The third one is computer-controlled routing. Okay, we will study the one by one. First, we will look into right-through routing. In right-through routing, the originating exchange determines the complete route from source to the destination. So here, let us look into the diagram. There are four exchanges which are interconnected in this manner. A is connected to B, B is connected to C, C is connected to D, D is connected to A. Let us assume this is the exchange or the subscriber connected to this exchange intends to speak with the subscriber connected to exchange C. So the communication should happen between the exchange A and C. Here if you can see, there is no direct connectivity between exchange A and exchange C. So in right-through routing, the exchange A itself decides how the call has to pass through from this exchange to this exchange. So this will decide. So let the call pass through via B. So then the call is established from the calling subscriber here to the called subscriber here in this exchange via like this, A to B, B to C. Or it may decide the originating exchange, the exchange from which the call is emanating or from which the call is made will decide. Or it may decide, say instead of this, it may say the call should be completed via D, A to D, D to C. So here what I want to impress upon you is the exchange A is having full controlling authority how the call to this exchange is to be connected. So here in this example, we have two paths, via B, via D. So this will decide. Let us look into it. This is the source exchange, this is the destination exchange. In the absence of computer, only a predetermined route can be chosen by the originating exchange. So since if we don't use the computer to help us in routing. So this exchange, originating exchange, will have a predetermined routes, particulars, how the call between A and C should be completed. Okay. However, there may be more than one predetermined routes, and the originating node may select one of these based on the criteria like time of the day, even distribution of traffic, and some other factors. So here in this example we have seen, so the call can be completed via B or D. So it will take a decision to route the call either via B or D depending on certain factors like the time of the day. Suppose in the morning session, let us assume the traffic in this direction is less from this exchange and more in this, then at that time it will direct its traffic via B. So on the contrary, during evening time or afternoon time, so this route is free, and at that time, so exchange may directs the call via exchange D. So it also ensures that the overflowing and even distribution also. It should not overload this route, the possible one route. At the same time, it should not overload this route A to D also. So it will search for the even distribution and it will see the time of the connection also. So this is the right through routing mechanism. Then we will, in this slide, we will try to understand now we will discuss own exchange routing or distributed routing. Own exchange routing or distributed routing allows alternative routes to be chosen at intermediate nodes. This strategy is capable of responding to the changes in traffic loads and network configurations. Another advantage of distributed routing is that when new exchanges are added, modifications required in the switch are minimal. So in one exchange routing, let us assume exchange A routes the traffic to B. B, the intermediate exchange, decides to via which exchange the call is to be routed. So in earlier case, the originating exchange has decided the path. Here, the intermediate station will decide through which path the call is to be sent depending upon the different factors or the traffic loads and other situations. So the intermediate station, the exchange, other than the originating exchange, the intermediate exchanges, as we have seen in the network topology with so many tandem exchanges. So the intermediate exchange will decide via which exchange the call is to be sent to the final destination. So distributed routing helps in other way also. When a new exchange is added somewhere in between the source and destination, so it calls for minimum modifications in the routing. So a few exchanges in and around the intermediate exchange if you make certain modifications, that is sufficient. Everything in all exchanges, you need not do modifications. Wherever the new exchange is coming, so adjacent exchanges, if you make some certain routing changes, that is sufficient. Next, we will see computer controlled routing. Computers are used in networks with common control signaling features. So in computer controlled routing method, we adopt the CCS signaling. We will have a separate discussion on CCS signaling. Here they have given the salient feature of CCS signaling. In CCS signaling, there is a separate computer controlled signaling network. So CCS, the beauty of the CCS is the signaling and the speech need not follow the same path between the source and the destination, subscribers or the exchanges. So signaling first signaling will be established between the source and the destination. It may follow a certain route and it may use its own trunk group. And speech can pass through some other path also. That is the beauty of CCS signaling, which we will discuss in detail in our subsequent lectures on signaling methods. With computers in position, a number of sophisticated route selection methods can be implemented because computers will have its own processing and decision taking capability. So the computer will decide depending upon the situation and the time of the call or the busyness in different routes. So it will route the traffic through the best available or the shortest and the best path available. So there are three types of routing we have seen. That is right through. The one exchange will control the routing. The other one, the originating exchange will decide how the call is to be established between source and destination. In one exchange routing, the intermediate nodes, they will decide the path from source to destination. Every intermediate exchange will take its own decision. Then in computer control, the brain in the computer so will decide the software program written in the computer programming will decide how the call between the source and destination is to be connected. So these are the three types of routing. Then further we will discuss some additional features of or merits or demerits of hierarchical networking. So this is the hierarchical networking which we have already discussed. Now we will see the other aspects of this hierarchical networking. A strictly hierarchical network suffers from one serious drawback. What is that? It's poor fault tolerance. So in case of fault, so this hierarchical network suffers a lot. That means, say for example, A to B, suppose if this call from A to B to the call B is to be connected, so strictly if you go by hierarchy, so it has to go like this and it is to be connected. So anywhere if there is a route disruption, communication disruption, so the call cannot be connected. So that's why they say it will have poor fault tolerance. So whenever fault occurs, there is a difficulty. A good network design should maintain communication in spite of reduced capability and increased blockage even in the event of a failure of one or several links. So the best network design should take care the possibility of interconnecting the subscribers even in the situation of reduced capability and insufficiency in trunks and increased blockage, so shortage of circuits, even in the event of failure of one or several links, even one or two links are failing. Say, for example, the link failure from PA to SA, this direction, or the link failing from this QA to TA. So also the call should mature by alternate choices. So that is how we have to design. Total breakdown of network should never occur unless under natural calamity. So something statewide or nationwide, some calamity, unforeseen calamity, sudden calamity happens. So in that situation only, so the network failure is permitted. Otherwise, for small inconvenience like a few routes failing should not lead to failure of the connection between the source and the destination or between the calling party and the called party. Further, we will look into this hierarchical routing, the pros and cons. In hierarchical network, as we go higher in the hierarchy, the nodes of each rank become fewer and fewer. A failure of a node or communication links at higher level leads to total failure of the communication. So as you go in the hierarchy, suppose if you go to tertiary center, this for understanding we consider as the main exchange, the trunk automatic exchange at state level. So this will be there for the entire state. So if you take one state like Karnataka as an example, so Bangalore is the TA, tertiary area exchange. So if Bangalore fails, so the entire Karnataka is isolated. So that is a serious drawback because there will be only one TA. If the connectivity between one SA and TA is isolated, means this SA, that is this district will not have communication. So this is a total failure of communication as far as this SA is concerned. Okay, suppose something happens at Bangalore exchange itself and it is failed, all the districts in Karnataka may fail. So this we have to take into consideration. Therefore, what we have to do, alternating routing paths and redundant nodes have to be provided for higher level supports. So that's why if it is considered as a state level exchange, so we should have alternate paths. So Bangalore is to be connected, say for example, via Chennai, via Hyderabad, via Nagpur, like that. Even one route fails, via other routes you can connect the call. So at higher level, as you go higher and higher, you should provide alternate paths. That means this higher level exchanges should be connected in a mesh form. Suppose if you consider this as Bombay, for example, this is the Western Zone Nodal Center. So this should be connected with other zones, not with one zone, preferably with all the zones. So that means Bombay should be connected to Bangalore, Bombay should be connected to Chennai, Bombay should be connected to Calcutta, Bombay should be connected to New Delhi. So somehow or other, the calls to Western zone should not fail at any cost. Okay, so that is the concept of it. The current tendency is to reduce the number of levels in the hierarchy and fully interconnect the higher level nodes to provide large number of alternates. So though the CCITT or the ITU has recommended 5 level of the hierarchy, what we have seen here, okay, 1, 2, 3, 4, 5. So the present trend is to reduce the number of levels even for international calls, and for a higher level of exchanges, higher level, you have to provide more number of alternate paths. The present national networks are built with only 3 levels of hierarchy. So the present day networks are generally managed with 3 levels instead of 5 levels originally suggested by ITU. Now, having understood the basic concept of the switching hierarchy and routing hierarchy, now we will see the same concepts from industry angle. So let us go through the contents. India as a whole is divided into telecom circles. So they are divided into telecom circle. What is telecom circle? Each state is a telecom circle, and the circle is known as LSA, local switching area. So each and every state is generally known as one circle. The technical nomenclature for the state is known as LSA, which stands for local switching area. As far as the present Andhra Pradesh is concerned, Andhra Pradesh and Telangana, they share the LSA headquarter at Hyderabad. So Karnataka, so it will have its LSA center. Karnataka and everything, entire Karnataka is one LSA, and the main LSA node is situated at Bangalore. So like this, Tamil Nadu, Chennai. Okay. So then Maharashtra, Bombay, like that. So each state is known as one local switching area. Each circle, that is each state, is divided into SSAs. So they are further divided based on the districts. Each district is generally known as SSA, secondary switching area, SSA. So district, you can say SSA. Each SSA is further divided into SDCAs, which are known as short distance charging areas. So each district is divided into, say for example, Krishna district in Andhra Pradesh is divided into 10 zones, sub-zones. Sub-zones means important areas. Each sub-zone will have its own exchanges. So 10 to 15 sub-zones. These sub-zones are known as, that is below the district level. It is something like old tahsils. They are known as secondary switching areas. Each SDCA will be having number of exchanges, and one nodal exchange in SDCA is designated as SDCC. So SDCC stands for short distance charging center. So as I told, each tahsil is one SDCA. and there may be 10 to 15 TASILs or SDCAs in our telecom parlance. So we have number of each SDCA will have a few exchanges which may range from, say for example, I am telling, it may vary from 10 to maximum 20 exchanges. So each SDCA or the subzone will have 10 to 20 exchanges. Out of these 10 to 20 exchanges, one exchange is designated as nodal exchange, and the technical name for that is SDCC, short distance charging center. I will try to give you one small example. I am taking the present EAP as an example. In this, I take, because I am speaking from Vijayawada, I take Krishna district as one unit. So Krishna SSA, or it is more popularly known as Vijayawada SSA district level, actually Krishna district level, we have different short distance charging centers, different SDCAs. So there are 10, including Vijayawada, Machilipatnam, Gudivada, Nandigama, Nujibiru, Jakkepeta, like that. Challapalli, Tirur. There are like 10 SDCAs. So each SDCA will have one exchange. One of these 10 bar 20 exchanges is designated as the SDCC. For example, for Machilipatnam zone, subzone, Machilipatnam is the SDCC, short distance charging center. For Nandigama area, Nandigama is the SDCC, like that. Each LDCA, long distance charging area, that is the district, will be having one LDCC, long distance charging center, which is nothing but a trunk automatic exchange or the old tandem exchange. Each district will have one tax exchange. Generally, they say it is level 2 tax. So for Krishna district, we have level 2 tax at Vijayawada. For Guntur district, we have at Guntur, and some other district, say for example, Karimnagar district in present Telangana, Karimnagar will have level 2 tax, like this. Here I am trying to display the hierarchy of the exchanges, how they are connected from industry aspects. So as we already discussed, so each district is divided into 10 to 15 SDCAs, short distance charging areas, and one of the exchanges in SDCA is designated as nodal center, and its technical name is SDCC, short distance charging center. In this example, I have taken Krishna district in the Andhra Pradesh, and I have taken only 3 SDCAs, though there are 10, because it is difficult to depict all the 10 here, because some district may have some 15 to 16 SDCAs also, depending upon the geographical area and the number of exchanges. So here I have taken one SDCA Vijayawada, another SDCA Machilipatnam, another SDCA Nujividu. So this is exchange A, this is exchange B, this is exchange C. These 3 SDCCs, or as a matter of fact, all the 10 SDCCs in Krishna district are connected to generally to its headquarter. Of course, Krishna is a special case for all practical purpose, or even in case of telecom, Vijayawada is considered as the nodal center in view of its geographical location and telecom connectivity is concerned. So these SDCA nodal centers or the SDCCs are connected to trunk automatic exchange at district level, that is Vijayawada. This is known as level 2 exchange. So this is also known as long distance charging center. This is further connected to level 1 tax, next higher level tax. Generally, it is a local switching area. So the circle. So the present AP Telangana, they come under single circle as far as telecom is concerned. The erstwhile Andhra Pradesh is one circle. So Karnataka is one circle. So it level 1 tax of Karnataka would be at Bangalore. The level 1 tax of Tamil Nadu will be at Chennai. So level 2 tax is connected to level 1 tax, which is connected to international gateway. Generally, the international gateways are located at different zones, the zonal important stations. As I already told once, they are at Delhi, Bombay, Calcutta, Chennai, Bangalore, through which the international gateway means, here I have given one example, Mumbai as the international gateway. Similarly, international gateways are available at other zones at Bangalore, Chennai, Calcutta, and Delhi. So for any international call from Vijayawada, say from Vijayawada to some other country, has to pass through from the subscriber and its exchange, then to this exchange, and from there to level 2 tax Vijayawada, then to level 1 tax Hyderabad, then to regional center gateway. Say in this example, I have given Mumbai, or it can be something Bangalore or Chennai or New Delhi, whatever it is. From there, it has to go to the other country. Say, for example, one place in the US. Similarly, other arrangement will be there in the other country. So this is how the call flows between source to the destination at different levels. Suppose if the call is between, say, from exchange A, Vijayawada to Newsweed, so it need not go to level 1 tax. So it is connected via level 2 tax at Vijayawada. Vijayawada exchange itself is connected to Vijayawada tax. Vijayawada tax is connected to Newsweed exchange. So the call will be like this. From Machilipatnam to Newsweed, the call is from Machilipatnam to Vijayawada, Vijayawada to Newsweed. So that is how the calls are connected between the calling and called subscriber. Here some more elements I have shown for better understanding based on the same concept what we have discussed in our earlier slide. So here I have added some more SSAs or LDCCs. So here I have taken some more districts. So for Vijayawada, same exchanges I have shown. Similarly, you will have Guntur. The STD code for Vijayawada is 0866. For Guntur district, the STD code, that is Guntur town, it is 0863. And Tirupati, that is for Chittoor district, it is 0877. So like this, all the 13 districts in the present Andhra Pradesh, they are parented to level 1 tax at Hyderabad. The STD code for Hyderabad is 40. Suppose if the call is to Chennai direction, so it will go to other level 1 tags. This level 2 tags is not connected to this level 1 tags or this level 1 tags. So generally it is connected to its own level 1 tags. This level 1 tags is in turn connected to the other level 1 taxes. A few level 1 taxes may not be all level 1 taxes. So it is possible with a few level 1 taxes of more interest. So from if it is international call, the call is sent to the international gateway. This international gateway may be depending upon the country to which you are connected, depending upon the connectivity of the international gateway with the international gateway of the other countries. So it may go say via Delhi or Bombay or Calcutta, or it may go via Bangalore or Chennai, something like that. So this is how different exchanges are connected as far as the industry aspect is concerned. I hope I could give you the required details both from theoretical aspect as well as from industry aspects. So as usual, I request you, if you like my video, please subscribe to my channel and also give an encouragement by giving a like. Thank you for participating in this session.